infinite limits. Now, suppose you have this function f of x is equal to 1 over x minus 1. Question is, what is the limit as x approaches 1 from the negative side, the left hand side, of 1 over x minus 1, and what is the limit as x approaches 1 from the positive side of 1 over x minus 1. Now, if we substitute 1 into this function for x, we're going to have 1 over 1 minus 1, which is 0, which is undefined, right? So, let's see what else can we do about this function to change up the way it looks. Nothing. So the limit at that point doesn't exist. Let's take a look at the graph of that function. 1 over x minus 1. 1 divided by x minus 1. Let's take a look at it. As x approaches 1, this is our one line. This line right along here is our one line. So let's go up and see what happens to the curve and the line. I see that the curve for the graph is getting closer and closer to the line, but not reaching it. Let's see what happens on the negative side down here. Again, the curve keeps getting closer and closer to the line x equal 1, but never reaches it. No, what you can say is that this line x equal 1 is the line that the curve approaches but never reach, right? From both the left, from the right hand side, the curve goes upwards. From the left hand side, the curve goes downwards. Now, that line x equal 1, the line which the curve gets closer and closer to but never reach, is called an, let me write it, an asymptote. This is called an asymptote. In this case, x equal 1. This line is a vertical asymptote. Now, can you see another asymptote there? Let's see. The curve seems to be getting closer and closer to the x-axis, but not touching it. It happens on the right, it happens on the left. So you have two asymptotes. The other one is this line, x-axis. In other words, it is where f of x equals 0, y equals 0. That's the x-axis. That's another asymptote, which is the horizontal asymptote, right? Now, the thing is, when you have that vertical line, for example, x equal 1, as f of x goes up and up and up, you look up further and further, like this, you see the curve approaches that line, right? As f of x tends to infinity, x tends to the value of the line. It approaches the line, but it never reaches it, right? So as f of x increases without bound, that means without end, no stopping, or decreases without stopping. Go down and down and down. What you have is that the curve, the graph, approaches that line, both from the left and right in this case. Alright? So that's what we have here. So in this case, the limit as x approaches 1 from the negative side, that's the limit of 1 over x minus 1. That's equal to negative infinity, because as you get closer and closer, approaches 1, the graph goes down and down towards negative infinity. You also see that the limit as x approaches 1 from the positive side, the limit of x minus 1 over x minus 1, is equal to positive infinity. Right? By the way, let me put back the graph to line up with my lines here. Okay, good. So you can see as you go up and up here, x gets closer and closer to 1. The graph shoots up and it goes towards positive infinity as you approach the graph from the right, positive direction. As you approach the graph from the left, which is negative, the graph shoots downwards towards negative infinity, right? So that's what you have there. Now, at the same time, while the limit as x approaches 1 from the left is negative infinity, and the limit as x approaches 1 from the right is positive infinity, the thing is, the limit as x approaches 1 of x, 1 over x minus 1, does not exist. Remember, one of the theorems says, in order for the limit to exist, the lines on the left, from the left and the right, must meet, and these certainly don't meet, so the limit does not exist. So what you look at here is an infinite limit, right? The limit goes up to positive infinity or down to negative infinity. So we have an infinite limit here.